So imagine I have two perfectly concentric circles, and I'm going to represent different measurements on those. If these small tick marks that I'm making are very tight together, that is something that is precise. So if we contrast that to some average measurements, something like that, this would be more accurate. Does it make sense, everybody, the distinction between accuracy and precision? So accuracy is more close to the true value. And so ideally, you have an instrument that is both precise and accurate. Is our objective, but we need to recognize that there's a difference in those two words. Next thing we're going to have is reproducibility and repeatability. So reproducibility is the reliability of this system. To reproduce measurements. So repeatability is variation in measurements obtained with one measuring instrument. We also have another term called bias. Which is a difference between an observed average and a reference value. Also interested in linearity. So this is the offset of those bias values throughout the system. We're also going to sneak in here the word resolution. That is basically the smallest change to, these are my words, to be observed. Or to be, it's observable. All right, so measurement systems analysis sometimes is interchanged with gauge R&R, which is that reproducibility and repeatability is what the R&R stand for. So now we're going to go into how do we execute one of these analysis of our measurement system. Is everybody caught up on those notes? Let's get over the, I'll leave the bottom notes. There are basically three ways that you can look at those. There's a range method. There's also an average and range method. And also what's called the ANOVA, analysis of variance. So I'm going to attempt to fill in this example of the average and range method here in a table. This is off of page 81. So please refer back to that to make sure we don't have any typos that challenge us. So we're going to have a situation where we're going to have 3 technicians and we're going to measure 5 parts. Typically, we're going to measure at least twice on the same specimen. So we have a first and second reading. And I'm not going to fill in this whole chart just so I don't lose myself, and you don't need to watch me write. So then we're going to have another column here called the thin part. And a range. And next bar. So the range of this is the difference on those. That's going to be 1, 1.5. These are the same as each other, so that'll be 0, 0.5. X bar is our average. Except I'm writing off the wrong column. So the average of 3 and 3 is also 3, and 7 and 5. Then tech. We also want this we called R2 and X bar 2. You know where we come up with R2 at? It's going to be 1.175.
So is your R2 your R1s added together and then divided by the 5? I don't have a calculator, so I can't figure it out. Is that what it is?
Well, I was trying to do it in my head. I don't Brian's usually pretty good with his in-head calculations. So this is the Rain Pen Tech. I was able to.
And then divide by 5.
No.
I think it's just your largest average from.
It's the
within
range.
part.
The range.
But that isn't your range between your top and, oh, unless it's a bid.
This is not good when you don't practice your problems before you get up on stage.
First set, 2, 1.5, 3, 2 is 1.5, and the range of the second set is 2. It might be 1.5 plus 2 averaged.
Yeah, so let's look down, and if you're looking in your book, we have another set of numbers. Let's see if that comes out right. So you said the range of the, which numbers do you have, 1.75?
Well, that first set vertically 2, 2, 1.5, 3, 2. The range of that is 1.5.
That's right, using these.
And then the range of the other one is 2. So if you average them out, it's 1.75.
Plausible.
The
Let's-
average of both of them.
We also have another column here. Let's see if that works.
First set, second set.
Yeah, that works.
Look at saying this is 1.5.
So this is the average of all
Well, here's what I'm going to propose we do while I chase this down, is that for today's exercise, I wanted to create a table like we have here for a series of parts. And so I have either a veneer item, we also have scales on the side, or some of you may have a rule with you in your notebook. So does that make sense? So I want you to create a table that has 3 people in a group. And I actually have, I think it's 9 or 10 of these plates that you can measure. And you can choose any of the features off of this to measure. In other words, you can either do the long or the short. It doesn't matter to me as long as you do them all consistently. On the back side of these plates, there's numbers on them. So everybody kind of get what I'm talking about? So my goal here before we leave is I want you to take 2 readings per person over 5 different parts. But make sure that the 5 parts that you do in your group are the same 5. Does that make sense? Is there any question about that? Because if you don't have the same plates in your tables, you will not get anything anywhere near useful. Yep, so 3 students per group, but if there's an industry person, you can have more than 3. So I do have